You probably use them every single day, maybe without even realizing it. They're in our scanners, our computers, our hospitals. But what exactly is a laser? How does this incredible, ubiquitous piece of technology actually work? Well, let's dive in and find out. It's kind of funny to think about now, but when the laser was first invented, nobody really knew what to do with it. It was this absolutely brilliant piece of physics, but it had no obvious job. Yeah, this quote right here, it says it all, doesn't it? A solution looking for a problem. Scientists had managed to create this incredibly pure, incredibly powerful form of light, but the world just kind of shrugged. They had the answer. They just hadn't found the right question yet. Well, as it turns out, there were tons of problems just waiting for this exact solution. Today, lasers are the invisible workhorses of our world. We're talking about everything from scanning your groceries and playing your movies to performing super delicate eye surgery, cutting through industrial steel, and even mapping the entire surface of the moon.
All right, so how on earth does it work? Well, believe it or not, the biggest clue is hidden right there in its name.
The word laser isn't just a cool-sounding name. It's basically the entire instruction manual. See, it's an acronym that stands for Light Amplification by Stimulated Emission of Radiation. And if we can just unpack that one phrase, we can pretty much understand the whole thing. And get this, it was this close to being called a loser. Seriously, for light oscillation by stimulated emission of radiation. And you know, a lot of physicists will tell you that oscillation is actually a more accurate word, but I think we can all agree they dodged a bullet there. Laser just has a much better ring to it. So what makes laser light so different from, say, the light from a light bulb? It all comes down to one single powerful idea: coherence. Think of a regular light bulb as a chaotic mob of light particles. We call them photons. They're all different colors or wavelengths, flying off in random directions. But laser light, oh, that's a disciplined army. Every single photon is an identical twin, same wavelength, same direction, all marching in perfect lockstep. And that discipline, that's where all the power comes from. And we build that army through a process called stimulated emission. It's basically a perfect chain reaction. First, you pump some energy into a bunch of atoms to get them all excited. Then you just need one single photon to act as a trigger. As it flies past an excited atom, it stimulates it to release a new photon that is a perfect clone of the first one. So now you have two identical photons, and those two go on to create 4, then 8, then 16. It's an incredible cascade of perfectly cloned light. Okay, so that's the physics behind it. But how do you actually go about building a machine that can do all that? It's actually a lot simpler than you might think. You really just need 3 key parts. First, you need what's called a gain medium. This is your fuel. It can be a solid, like a ruby crystal, a liquid, or a gas. Second, you need a pumping energy source. That's the spark, like a flash lamp, that gets the fuel all excited. And finally, you have the optical cavity. This is the amplifier. It's basically a pair of mirrors that bounces all those new photons back and forth through the fuel over and over, building up that disciplined army until it's an intense, powerful, focused beam. And once you can control that process, well, that's when things start to get really wild. The number of things you can do with it is just staggering. I mean, they're literally everywhere. Lasers are the backbone of our internet, carrying data through fiber optics. They're a surgeon's scalpel. They're an industrial cutting torch. They're a vital tool for scientists making new discoveries. It's hard to find any part of modern life that hasn't been touched by them. And the scale of power here, it's just immense. We go from a couple of milliwatts in the little laser pointer you use for presentations, all the way up to thousands of watts for an industrial cutter that can slice right through thick steel. But that's just the average power. When you start talking about peak power, things get truly mind-bending. So right now, the most powerful laser in the world can reach a peak power of 10 petawatts. So what on earth is a petawatt? That's a 10 with 15 zeros after it. 10 quadrillion watts. For just a tiny fraction of a second, that one beam has more power than every single power grid on the entire planet combined. And why would you need that? Well, scientists are using it to try and replicate the conditions you'd find inside a star, all in the hopes of cracking nuclear fusion. So if we've come this far, where could this technology possibly go from here? The future looks, well, pretty bright. So let's circle all the way back to the beginning. What is next for this amazing technology that once seemed to have no real purpose at all?
Well, some of the stuff researchers are working on now sounds like it's straight out of science fiction. They're developing white lasers that could one day replace all of our current lighting, silicon lasers that could build the speed of light directly into our computer chips, and maybe the wildest of all, biological lasers. They're using genetically engineered living cells to produce a beam of laser light. It's just unbelievable.
So yeah, that solution looking for a problem definitely found its purpose. In the process, it completely reshaped our world. To go from a simple lab curiosity to trying to build a star here on Earth, it just goes to show you sometimes the most world-changing answers show up long before we even know the right questions to ask. The story of the laser is definitely not over.